So, yes, I will speak about some cities in a new way, let me say, because we have started as a startup 3 years ago, but we are working on this project since 2019. And what we do is that, firstly, like many other, let me say, innovation, we started from looking at reality. What is happening now is that LED is really over-illuminating our cities. So there is a lot of light pollution around. We have discovered that, but I mean, the European Union has already recognized this phenomenon since a while. So there is a specific policy that, let me say, can be applied, that is telling you, if you're able to understand what is the level of traffic on the street, then you can make the comparison between that level of the street and the street lighting classification of the street. According to that, you can declassify or classify up the street level lighting. But this gives, let me say, a dynamic lighting that is not really applied today in our cities, but it's a pity because, of course, for example, when you leave your house, you don't leave all the lights open. It shouldn't be like that also in the street lighting. Of course, you never close the light in the street lighting, but you can dim different levels according to the occupancy of the street, and the European norm goes over this direction, introducing adaptive lighting. So this norm is not really not that frequently applied, it's barely applied. Why is it that? Because basically to apply that, you need a specific sensor for each specific street, or at least one sensor for the main street, and you can replicate the same amount of light for the other streets. But this is not very efficient, because of course, in the main street you have traffic till very late, while in the secondary street, maybe you don't have traffic till very late. So it's not very efficient to replicate the same model of the main street to the other streets. So you put a standalone sensor, and you need an element, which is a light control element, to communicate with the single street lamp. What we have done of different from this architecture, let me say, we have done everything within the light control system. So how we have done it, most of the times the light control element is upon the street lamp. So it can be placed upon or down the street light. It depends on the choice of the designer or the street lamp, who has decided the street lamp. Within that element, we have integrated sound recognition by using a microphone and neural networks. In this way, we're able to understand what is happening outside, classifying the soundscape, that's how we call it. And in particular, we are able to quantify the traffic to make the adaptive lighting that I was saying to you before. This works, let me say, a little bit more. It's a little bit more complex than simply, let me say, understanding something that is happening and lighting up, lighting on and off. It's more complex because we need to follow the rule that I will say, the norm that I was saying before. So every 10 minutes we need to. First, we need to know the classification level of the street in terms of lighting. Then we need to have the element in place, and every 10 minutes we need to make this comparison that I was telling you before. The quantity of traffic in comparison with the street lighting street lighting plan regulation. And then we can jump up or down 2 categories. This introduced significant savings. So now we have 12 plants active. In our experience, you are a little above 50% on average on the energy saving that you have in comparison to not dimmed lighting. Because let me say the other main practice that is used in the market is fixed profiles of lighting. So after midnight, maybe the light goes down 13% without knowing what is happening around. But you understand that this is against the norm that we were seeing before, and it's not very, it's not optimal. So with this instrument, you adapt the lighting to what is really happening on the street. and the saving is really significant. 50% reduction of energy means the same probably amount in reduction of light pollution, or even more. Because the light pollution that you have is that basically the light goes down on the street and comes back. So if you can reduce the initial flux, then the light pollution that you reduce is even more. We have understood that we are able to do many things, not just counting cars, but also other things by doing, let me say, our development. So we understand the typology of traffic. We understand light vehicles and heavy vehicles because they emit different sounds. If you just stand by near your house, for example, nearby the street, and you close your eyes, you are able to detect that, I'm sure, if it is a truck or it is a car. We can do the same. I mean, we are doing the same. We are a phone meter, so we can tell you the level of exposure to noise, so equivalent noise level and peak noise levels. We understand very much the rain. Why is it that? Because one of the first things that was disturbing our car countings was the rain. I mean, when it rains, especially because usually we are placed upon the lamp, we didn't understand what was happening, okay? We were counting many cars. It didn't make any sense. And then we understood that the problem was that one, and we have become really good at understanding the intensity of rain and the duration. And this could be, unfortunately, interesting for communities here in Valencia, but in Emilia-Romagna as well, we had many floods. And okay, maybe it's late, maybe no, but this can be an additional alerting system, and it is exploiting the distribution of the infrastructure, light infrastructure, which could be very, very, very wide. Of course, you have meteo stations in cities, but they can be maybe one for a municipality. Instead, maybe the average municipality in Italy is a 1,000 light pole. So it's different. It's not just one. Then, of course, the accuracy is not the meteo station one, but it's a good one. Okay, so the key of our system is that, as I was telling you before, we are not just on Main Street. We are on all the streets, because if you want to speak with the lighting, with the street lamp, you need that kind of element on the light, even to know its status. But we have done a little step above, we think, because we give the possibility to dimming adaptively on every street, because you don't need any additional sensor, any additional element. It's just a light control element of the lamp. We can do many, beside the things that I was telling you, the other thing is safety. Sound, with sound you can understand some safety things happening around the city. We are working on that. Right now we are just good, let me say, at understanding sirens. Very, I mean, trivial it seems, but I mean, if there is an ambulance passing by, or if there is an alarm on the street, we can just stay 100% immediately. I mean, if the municipality gave us the possibility to do that. Then the other thing that is very important of our system, and is linked in some way to safety, is that it's GDPR compliant. Similar to the intervent to the previous speech of the professor, we have the intelligence directly on the final edge element of the IoT structure. So we classify what we hear directly there, and what we store in our cloud, in our storage system, is not sound, is not streaming, it's just classifications. So just a bit of strings, let me say. So nothing that is connected to the personal data of the persons. Yeah, many people ask me, but what about electric vehicles? Yeah, electric vehicles could be a pain in some way, but they are not in the end, because above 20 kilometers per hour, what we listen is just the friction of the tire to the surface of the road. Above 50 kilometers per hour, we just hear the movement of wind, because we are up, you know, we are 6 to 9 meters up on the street. So it's not really the same thing to be exactly next to the street. The electric vehicles, below 30 kilometers per hour, they need to emit some alertic sounds. Maybe you've heard some. They're not much noisy, I have to say, but still you can hear that. And they are very, they are differentiating themselves. Toyota is making one sound, BMW another one, Audi another one as well. So we can even tell in the city center is passing 200 BMW, they are passing 200 BMW a day, 100 Toyota, something like that. Honestly, we have not focused on that, but we can do that. So right now we are counting in general cars, but we can also distinguish at low speed if they are electric or if they are not. Yes, the system today is one of a kind. We are the only one who has linked at the moment in this specific light control element, the light control and the sound sensing. The main advantage is, of course, that you can make some energy saving, and this is helping us, let me say, to get into the market because it matters a lot, of course. But also the fact that it's very easy to apply and quite easy to spread around the installation, the light infrastructure. This is how it's sold, but honestly, it's not the element of our discussion today. We just wanted to, my mission is just to introduce a new application in the market. The thing that is different for me, sorry, I think I got to the wrong slide, but anyway, is to all the data that we get. When we make efficiency, of course, it's very easy to sell efficiency, let me say. But when we collect data and this knowledge, till we don't maybe connect many light points, it's difficult to make value on this data. Of course, I hope in the next years we will find a way to make it market, to let some clients have a really efficient use of this data. But today, of course, they are just data they look at, but still, or they don't want to pay, or they don't know exactly what to do. They say, interesting, but honestly, it's not the main way that the solution is of interest now. Mainly, it's light efficiency at the moment. But honestly, this is in the future. I hope it will change this aspect, and especially, I think going towards the specialization towards security of the cities. So understanding, like for example, when there is someone asking help, and understanding also if on the street side, let me say, when there is some accident on some specific tire sounds that is about to happen an accident, if we are able to understand that and give that information, I think this will be more understandable for our customers, which are mainly, though, energy company. So at the moment, so they are very keen on energy saving. The other things, they say, interesting, but we need to speak to a different kind of people within the municipalities, and so it's a different business. So let's see what we'll do step by step the next years. We apply the element to the street lighting industry, but it can be applied efficiently also to the industrial segment. Whenever you have basically a kind of lighting which is professional in some way and has a certain dimension, it can be equipped with this connector. It's called Zaga connector. Basically, I don't know, Philips is selling you the street lamp as a standard and the street lamp with the Zaga connector. So wherever there is a Zaga connector, and this is happening also frequently in the industrial segment, we can be there. And of course, in industrial, the use is different, but still with noise, you can do a lot. And it's also interesting for private, let me say, segment, industrial segment, the fact that you can use the data, let me say, without asking several permission, because it's a classified data. So you can maybe find clever way to dim according to the noise level that you understood, that you understand, and you can make specific trainings of sound events that you want to recognize. Yeah, this is this is us, the three co-founders. Now we are a team of 15 people, more or less, and mostly active in Italy today. The plants that are active at the moment are in Italy, but we are looking to spread around, so that's why I'm here. Thank you very much for your attention, and we keep in touch.